Hi, welcome again. And so today we are going to work on problem number 2 for optimization. And we are going to look at optimization on examination. And so the problem says a student did his first exam and got 75 out of 100. And this exam constitutes 30% of the total. The student has two more exams to fulfill. One constitutes 30% and the final 40%. The student needs to score just 90% to become an honor student. So you can see that this student doesn't need to score more or less, but they just need this particular value. And if you can go back to the summary, which we have, especially on the objective function, so the objective is not to maximize or to minimize, but to get a particular value. For us to be able to advise the student on what he or she should get for the second exam and for the final, we have to create a model. So we can create our model as follows. So here we have student, and the student is doing exam. I'll say the student has 3 exams. And so we have first exam, and then the second and third exams. So let me copy this and paste. So I'll remove the first exam from the row. So I can say here is exam, and then the student scores. So here the student scored 75 in the first exam, and the percentage which this exam constitute will be 30%. And so we can see the total contribution of this exam. And to find the total contribution, if this constitutes 30%, then we can put equal sign, click on 75 times 30% and enter. So I'm going to change this to be 30% and enter. So it will be 22.5. Now the student has to do the second exam and the third exam. The second exam will constitute as well 30%, but the fourth exam constitutes 40%. So in this case, we can see the contribution of the total, and that will be 100%. But the student has not yet done the second exam, so we can put any value. Let's say we can put zeros, and we can highlight this and give it the color. Let's say yellow, and let's define the yellow color. So that is changing variable cells. And so here we can write the total. And so we have the total, which is 100%. We can also even include another total, which we sum all the exams, and so the student has scored only 75. The student needs to fulfill these 2 other exams. Also, we can see the contribution of these 2 exams and put in the equal sign, take this times 30, or we can actually copy the formula where we take the exam times its the contribution to the total. So we will copy this formula way down to the third exam, and we can find the total. Type sum, and then we are looking for the total of those exams. And so we have 22.5 at this moment. So exams are out of 100. So that means the student can score 100 or less, but not more. So, and the limits will be less or equal to the constraint. and the constraints will be 100. And so we can do for all the 3 exams, and also we can copy the constraints for the 3 exams. Now the total contribution to the exam will be the objective, and we need this to be 90. So let me highlight it differently, and I will define the color to be the set objective cell. And so then we can actually add the non-negativity condition. So I'm going to copy the first exam, paste it here, and then I can copy all those 3 exams, and they should be greater or equal to 0, greater or equal to 0. And so in this case, we can copy this way down to the second exam and the third exam, and also the first and second exam should be greater or equal to 0, meaning that you cannot get the negative of the exam. And so we can use solver because our model is already defined. So let's go to the solver. All you have to do is click on the data and you get the solver. If you still have it on your computer, but you can still add in the solver. And so we will look at the set objective, and it's this color, which means it is this. And then we are not maximizing, we are not minimizing, but we are looking for a particular value, and that particular value should be 90. And we can obtain that particular value by changing these variables. And so we will highlight these variable cells, but we need constraints, and our constraints will be based on these limits and these limits. And so I'm going to add the first set of constraints, and this will be the values which will be less or equal to 100. And you can see these are not the values, but these particular values. They should be less or equal to 100. And so will be these two, and those two should be less or equal to 100. So let me select the corresponding 100. We are not selecting 75 to be less than 100 because already the exam is done. We can add these constraints, but before we add these constraints, I need to define them here. So all I can do is just to cancel, and I can close. And so I need to define the values for the first exam. So you can put equal sign, not the first exam, but the second exam. You can put equal sign, and you can select the second exam via a cell. So you can do the same for the third exam, meaning that if you change those exams, they will also change here. So now we can go back to the solver, and everything remains the same. Now we're going to add constraints. We don't have our constraints here, so I'm going to add constraints. So the first set of constraints will be these 2 exams should be less or equal to their corresponding values, which is 100 for each. And then I'm going to add another constraint, and that will be these 2 exams, meaning that these 2 exams should not be less than 0. So it should be greater or equal to their corresponding values, which are zeros. And in this case, we are all set. And so I can click OK. And all I have to check is to make sure that we are focusing on a particular value. I can check the set objective, which is E8, which is there. You can also look at the changing variable cells. These are the ones. We can verify the constraints, which we have this one set and the other set. And so here we make all unconstrained variables non-negative, but we have to use the simplex linear programming algorithm, and so we can solve. Now you can see all constraints and optimality conditions are satisfied. And so I can keep the solver solution. I can provide the sensitivity analysis and so forth, but at this time, let me just click OK. Now, in this case, you can see that the student can score 90% to be an honest student if he or she scores 91.6 for the second exam and got 100 for the third exam. So if the student scores 90, he or she will not be able to get 90. So the student should get more than 92% for the second exam to continue with the third exam and get 90. But if the student get 92, then that means the third exam has to get 100. Now, what if the student get 96? Then there are more opportunities for this student to get something a little bit less than 100 for the third exam to score 90.